Good morning. In this video, I would like to explain about small sample test. In the small sample test, I would like to explain about t-test for 2 mean. Now let us see the procedure of t-test for 2 mean. In the last video, we discussed about the small sample test, that is the sample size value n less than 30, then we are going to conclude a small sample test. We discussed the problems in the last video of t-test for single mean. Now let us check the procedure of t-test for 2 mean. So whenever we are having two sample sizes, the two sample sizes n1 less than 30, n2 less than 30. So whenever we are having two sample size, obviously we will get two sample means, so that it should be defined in terms of x1 bar and x2 bar. So now we are going to define the process of t-test for 2 mean is, let x1 bar, x2 bar be the means of the random samples of sizes n1 and n2. It has been drawn from the two normal populations with two population means. Now the population mean, it should be denoted by mu, and we are going to define as having two random samples. It has been drawn from the same normal population. So we are going to defining about two population means named with mu1, mu2. So in order to finding out all the 5 steps procedure, the first step we are going to define it as null hypothesis. So null hypothesis means a statement of no difference is called null hypothesis. Now we are going to check these two sample sizes n1 and n2. It has been drawn from the same normal population. It means that we would like to check whether there is any significant difference between two population means or not. So we are going to define the null hypothesis is h0 is equals to mu1 is equals to mu2. It means that there is no significant difference between two population means. Now let us see the second step of alternative hypothesis. So alternative hypothesis means the statement against the null hypothesis is called an alternative hypothesis. So we are going to define H1. So H1 is, it means in the given problem they are asking to finding out whether there is any significant difference in the given data. So if they are asking there is any significant difference in the given data, the test it will be a two-tile test. So we are going to write our alternative hypothesis H1 is, the test it will be a two-tile test. So the third step is, as usual, we are having the level of significance. In the problem, if they did not mention anything, we would like to find out the level of significance at 5% level of significance. If they are asking to check whether the level of significance at 1%, we have to follow the table value of 1% level of significance. So now in the problem of t-test for 2 mean, we are having two sample sizes. So we will get two sample means. So the test statistic it will be, t is equals to x bar minus y bar by s root 1 by n1 plus n2. S root 1 by n1 plus n2. So now it follows, now you are going to defining about degrees of freedom, that is the number of independent variates which make up the statistics. So here we are defining about two sample sizes and it follows the degrees of freedom, it will be n1 plus n2 minus 2 degrees of freedom. So it means that we are having the two sample sizes. For example, we have the value of n1 is equals to 10 and we have the value of n2 is equals to 8. So obviously it follows, means the table value we are going to define it as n1 plus n2 minus 2 degrees of freedom, that it will be 10 plus 8 minus 2, 18 minus 2. We have to follow 16 degrees of freedom at 5% level of significance or 1% level of significance. We are going to conclude our given problem. So now this is about our test statistics and we should find out the value of S. Suppose for the given problem, if we have the values of S directly, we are going to substitute that values. If value of S is not there, it means that we are having the observations of two sample sizes. We would like to find out the value of S is equals to square root of n1 s1 square plus n2 s2 square by n1 plus n2. So this value we are going to substitute in the test statistic T. And the last step, we are going to finding out the fifth step, conclusion. So now the conclusion it will be the calculated value of t. So if any case, if the calculated value, if we got it as a negative value, we are going to check the calculated modulus value of t is less than the table value of t. If the calculated value of t is less than the table value of t, we have to accept our null hypothesis. So accepting H naught means, as the given problem, if you are having two means, we are going to conclude that there is no significant difference between the two population means. So we are going to accept our H naught. If any case, it means that if the calculated value of t is greater than the tabulated value of t, we have to reject H naught. It means that the two samples, there is some significant difference between the two sample sizes, and we are having these samples, it does not has been drawn from the same normal population. So this is the process of t-test for single mean, two mean, as well as we are going to conclude the tabular forms. The tabular forms, it will be of two-tile test and right-tile and left-tile test. So as like as our t-test for two mean, so if the problem, the alternative hypothesis, it will be a two-tile test. Alternative hypothesis, it will be a two-tile test. We are going to follow the table value, it will be t alpha by 2, that is 0.025. If any case, if the alternative hypothesis, if it will be a right-tile test or left-tile test, then we are going to follow the table value is at 5%. It means 5%, or 1% means we have to follow the table value is at 0.01. Then the same process, whatever we have to follow on the t-test for single mean, we have to follow the same procedure of t-test for two mean also. But we are having only the difference is to change out the formula of t is equals to x bar minus y bar by s root 1 by n1 plus n2, and it follows the degrees of freedom as n1 plus n2 minus 2. Now let us see the problem on t-test for two mean. The samples of two types of electric bulbs were tested for the length of the life, and the following data were obtained. We are having the data of two types of data. It means that we are having two samples of sizes. The two sample sizes are n1 as 8 and n2 as 7. It means that the two sample sizes are less than 30. So the problem belongs to t-test for two mean. It means if two sample sizes are there, obviously we are having two means and two standard deviations. So we have to conclude that based on the given data, the problem is on t-test for two mean, and it is on small sample test. Now let us see the first step. So before going to the problem, so now let us see what they are asking in the given question. Is the difference in the means sufficient to warrant that type 1 is superior to type 2? So it means that in the given problem they are asking that type 1 is superior to type 2 regarding the length of the life. So it means that as in the last video we discussed about alternative hypothesis that type 1 is superior to type 2. It means that if the terms in the given question, superior, increasing, larger, if these terms are there in the given problem, we are going to check the test of alternative hypothesis belongs to a right-tile test. So now let us see the first step of null hypothesis. So null hypothesis H naught, we are going to check the two types of bulbs are identical. It means that we are going to follow the null hypothesis, a statement of no difference. It means the two types of electric bulbs are identical. We are going through like that. So it means that H naught is mu1 is equals to mu1 is equals to mu2. It means that the two types of electric bulbs are identical, or you can conclude that there is no significant difference between two types of electrical bulbs. So now let us see the second step, alternative hypothesis. Alternative hypothesis means here the statement against the null hypothesis, we are defining it as H1. So in the given problem we have to observe the given question that type 1 is superior to type 2. So it means that the value of H1 is mu1 greater than mu2. So if any case mu1 greater than mu2, the type of the test, it will be a right-tile test. So in the given problem, as well as they didn't ask to check whether it is at 5% or 1% level of significance. If they did not mention anything in the given question, we have to follow at 5% level of significance. So we have to choose the level of significance is at 5%. Now let us go with the test statistic. So the test statistic, both are two samples. It is of small sample test, and we are having two sample means. So the test statistic, it will be here t is equals to x bar minus y bar by s root 1 by n1 plus 1 by n2. It follows t with n1 plus n2 minus 2 degrees of freedom. So in the given problem, we are having two types of standard deviation. We cannot find out the two types of standard deviation, and we can finding out the value of s is equals to square root of n1 s1 square plus n2 s2 square by n1 plus n2. We can finding out the value of s by using this formula. So now we have to substitute the given values. That is what? The value of n1 is 8 and the value of s1 is 36 whole square plus the value of n2, it will be 7, and s2 square, it will be 40 whole square by n1 plus n2, it will be 8 plus 7. So taking the square root of the term of the value of s, we will get the value of s is equals to 40.73. So now we have to substitute these values in the given test statistic. That is what t is equals to. The value of x bar. First sample mean of the size here, it will be 1234 minus 1036 by the value of s we got here, it is 40.73. Square root of 1 by 8 plus 1 by 7 follows t with n1 plus n2 minus 2, it will be 8 plus 7 minus 2 degrees of freedom. So now let us see the calculated value of t is 9.39 and it follows the degrees of freedom. Here 8 plus 7, 15 minus 2, it means that we are going to follow at 13 df. And we are going to finding out the level of significance. In the given problem, they did not mention anything, so actually we have to follow at 5% level of significance. But here, the type of alternative type of test, it will be a right tile test. If it is a right tile test, we have to follow the level of significance at 0.05. At 0.05 level of significance, the table value of t, we are going to finding out t tabulated value. Now the tabulated value of t is 1.771. So now let us conclude the calculated value. Here it is 9.39 and the table value is 1.77. So it will be greater than. So we are going to conclude here the calculated t is greater than the tabulated t. So it means that we have to reject our H0. So rejecting H0 means the given null hypothesis. As in the given problem, we consider that the two types of electric bulbs are identical. So reject H0 means obviously we are accepting H1. So accepting H1 means the type 1 is superior to the type 2. So and we are going to conclude, therefore the two types of bulbs are not identical. Therefore the two types of bulbs are not identical. So in this way we are going to conclude the problem on t-test for 2 mean. Now let us see the problem on t-test for 2 mean. So we have two independent samples of items respectively which had the following values with the values of x and y. So these two samples having the sizes of less than 30. So we are concluding this is the problem on small sample test. So is the difference between the means of sample significant? As before problem we are having the direct values. Now in the given problem we have two samples of sizes. It means we need to find out the values of x bar and y bar and standard deviation also by using these two values, and we can conclude is the difference between the means each samples is significant or not. So now let us see the first step of the given problem. The first we have to set up our null hypothesis, that is H0. So we are going to check that there is no significant difference between the two types of means. So it means that we are taking the values of H0 is mu1 is equals to mu2. So this is our null hypothesis because they are asking in the given problem, is the difference between the means of samples significant? It means we are taking there is no significance difference between the two types of samples. So we are taking H0 is mu1 is equals to mu2. It means that these two samples has been drawn from the same normal population. So now let us see the next step, the alternative hypothesis. As in the given problem they did not ask to find in future is they are going to increase or superior. So it is not belongs to two tile or left tile test. So the now alternative hypothesis it will be H1 is mu1 not equals to mu2 and the type of test is two tile test here, And in the given problem, they didn't ask to find out either 5% or 1% level of significance. So preferably we are choosing at 5% level of significance. So we go through the next step. The level of significance is at 5%. And the fourth step is the test statistic. Clearly we are having t is equals to, it is two sample means problems. T is equals to x bar minus y bar by s root of 1 by n1 plus 1 by n2. And it follows t with n1 plus n2 minus 2 degrees of freedom. So, but in the given problem, we are not having the values of x bar and y bar and standard deviation. We need to find out all these values by using the tabular form. Now, let us see the tabular form we are having with the values of the first x values. The first x values are 11. And the next column we are going to finding out the values of, because we are having the formula of, here we need to find out the formula of s is equals to square root of 1 by n1 plus n2 minus 2 summation of xi minus x bar whole square plus summation of yi minus y bar whole square. So by this we are going to finding out the value of s, but we are not having the values of x bar, y bar. So we are going to finding out all these values by using the tabular form. So first column we are going through x values, and the next column we can go through the values of x minus x bar, and the next column we can go through x minus x bar whole square, and the next we have with y values, and the next we have with y minus y bar whole square. So this is of y minus y bar, and the next column we can go through y minus y bar whole square. But here these two sample sizes are not, the sizes are not equal. One sample is in 8 observation, one sample is 7 observation. So now the sample 1 is 11, 11, 13, 11, 15, 9, 12, 4. This is about our first sample observation. So the sum of the first x, the sum of which x is 96. We are going to finding out first x bar value. So the value of x bar is equals to summation x by n. So we are going to finding out the values of 96, and we have the sample of observations 8. So x bar 96 by 8 is equals to 12. So now the thing is, we are going to finding out 11 minus 12. 11 minus 12 minus 1. So minus 1 whole square. So it will be minus 1 whole square. Next 13 minus 12, 1, 1 square. 11 minus 11, 0. It will be 0. Next 15 minus 12, 3, and 3 square, 9. And again next 9 minus 12, 3, 3 square, 9. And next we have 12 minus 12, 0. And we have 4 minus 12, 8. It will be minus 8, it will be 64. Now the thing is, we are going to finding out summation of xi minus x bar whole square. It will be now 14 minus x bar 12, 2. So 2 square it will be 4. Now the summation of xi minus x bar whole square, it will be 26. Now let us see the values of y observations. So y we have 7 observations. So it will be 9, 11, 10, 13, 9, 8, 10. So one more observation is not mentioned in the given problem. So we need to take it off. Y is equals to of 7 observation. Now we are having the value of summation y is equals to 70. So we are going to finding out the value of y bar. So now let us see the value of y bar is equals to summation y by n. So it will be 70 by 7 is 10. So the value of y bar is equals to 10. We are going to finding out the value of y minus y bar whole square. So 9 minus 10 minus 1. So it will be 1 square. 11 minus 10, 1, 1 square. 10 minus 10, 0. So it will be 0 square. 13 minus 10, 3. So it will be 3 square, 9. Again 9 minus 10 minus 1, 1. 8 minus 10 minus 2 square, 4. 10 minus 10, 0, 0. Now we are going to finding out the summation of yi minus y bar whole square. So it will be 16. So the first thing we are going to finding out, before going to finding out the value of t, we are going to finding out the value of first standard deviation. So the value of s is equals to square root of 1 by the first n1 plus n2 minus 2. It will be 8 plus 7 minus 2 into summation of xi minus x bar whole square. It will be 26 plus yi minus y bar whole square, it will be 16. So it will be 26 plus 16. So if you simplify this value taking the square root of this, we are getting the value of s is equals to 1.8. So substitute this s value in the test statistic. So it will be t is equals to x bar minus y bar. It will be 12 minus 10. So 12 minus 10 by 1.8 into root 1 by n1 plus 1 by n2. It will be 1 by 8 plus 1 by 7 follows n1 plus n2 minus 2. So n1 it will be 8 observations and n2 it will be 7 observations. So it will be 8 plus 7 minus 2 degrees of freedom. So it will be 15 minus 12, 3 degrees of freedom. N1 plus N2 minus, so it will be 2 degrees of freedom. So the calculated value of T we are going to finding out. The calculated T is now 2.15. So the calculated T is 2.15. Now 15 minus 2 we have to follow at 13 DF at 5% level of significance. The table value it will be 2.16. Now let us see, we are going to the fifth step of the conclusion. The calculated T is 2.15 is less than the table value of 2.16. So therefore we are accepting H0. We accept H0 means as our null hypothesis we are taking that there is no significance difference in the two population means. So we are concluding that our given data is correct. These two sample sizes it has been drawn from the same normal population. Now let us see how to check the table value for this problem of t-test for 2 mean. So here the alternative hypothesis it will be two-tile test. If it is a two-tile test we have to follow t alpha by 2, it means 0.025 level of significance. So we are going to finding out 13 DF. 13 DF we are going to finding it on the left hand side and we have to follow 0.025 level of significance. So we are going to finding out here 13 degrees of freedom on the left hand side and 0.025 here the value it will be 2.16. So that here we are going to conclude the value it will be 2.15. In this way we have to check the table values. So in this problem let us check how to check the table values. Here the alternative hypothesis it will be a right tile test. If the problem alternative hypothesis it will be a right tile test, we have to follow the level of significance at 0.05. And here the table value follows n1 plus n2 minus 2, that is 8 plus 7 minus 2. So we have to follow 13 DF. Here 13 DF based upon the right tile test we have going through the table value. So 13 DF here it is we are following on the left hand side and 0.05 it will be 1.771. So we are going to conclude here the problem is 1.77 is our table value. So we are concluding calculated T is greater than the tabulated value and we are concluding the rejecting H0 and the two types of bulbs are not identical. Thank you.